Hey, okay, here's my ChainLink coin list hackathon submission. It's called plasmaLink. So this has been a really good hackathon. The workshops are great. The Discord support was pretty amazing. So all in all, it was a really good experience. And the product, ChainLink, it really demonstrates the possibilities of smart contracts and a smart approach to how you utilize them. Okay, so what I built is essentially a D app, and it's connecting to the Ethereum blockchain with ChainLink running on top of that, and its smart contracts. So for the Plasma piece in sidechain, I'm using Loom. So Loom is a pretty strong product. It's probably one of the leading layer 2 solutions right now. One big advantage they have over a lot of things is they're in production. They have a bunch of transactions going against them right now. We see here, I mean, some pretty decent volume they're putting up on a daily basis for their mainnet. And there are a bunch of things that are getting pretty popular that are getting built on top. So they're leading the way in a lot of things for layer 2 solutions, especially as we wait for Ethereum's next release to come out. Okay, so for what I have here, we have a couple things, a couple options. One, we can go to the demo. We have this video that we're watching right now that you can link in from the solution here. And then we have an overview of the approach, but that really just talks a bit about what I talked about now. Okay, so let's start the demo. So we have the Ethereum piece that I showed here. So here's the address we're using. It has some Ether on it. So it's injected from MetaMask. So we can see that here, and it has some link tokens. So we can see these balances match. And what we want to do is we want to fund some link into our contract. So we have enough of a balance here to be able to invoke things. So every time we invoke a ChainLink contract, we're paying a link token for that invocation. So we also have the Loom piece here. So our Loom contractor, it has a contract on that network. So this is their testnet, xdev. It's at this address. It's counting these skills. So that's just an arbitrary thing that we kind of pick for this demo. So if I just refresh, you'll see some skills here somewhere. Okay, so here's a bunch of skills. If we zoom in a bit, so this is just an arbitrary piece of data that I picked from a contract just so we could demonstrate what we're trying to demonstrate. So we have some skills, and then we have some things we're adding either directly from, so here directly from Loom, or actually through an adapter from a ChainLink contract that then gets to Loom. And for those, we have a little different, a direct contract add versus added from ChainLink and timestamp. So it's just something to understand about what's going on in the background. Okay, so the process, like I said before, is we have this app. It calls a ChainLink contract. That contract does an HTTP through the Oracle, runs a job, and then hits our plasmaLink adapter concept. And then that will actually make it to the Loom network. And then when it wants to read a value, the same thing happens. Those values then are stored against this contract that we're going to show you in the demo. Okay, so the first thing to do is, so we have 13 skills here on this Loom contract running in the network. So if we read against this ChainLink contract, we actually only have 12. So last time I ran this, this was at 12, and that's stored against the contract. So what we can do is we can invoke that ChainLink contract that we wrote, and then that will go against that adapter and then hit the Loom network, and actually then store that in this contract, and that should be 13. So it's going to take a few seconds to run. So do that. While it's running, I can show you a couple of things. So here's our address. If we look at it, we'll see a bunch of out transactions. Those are all link tokens that we're sending to fund the contract. And then here, this is our ChainLink contract. This is the one that's helping facilitate these. Okay, so we have a confirmation. So actually, if we go back here now, and we were to read this contract, we should get the correct value. Not yet. Still not yet. So we'll give it a second. So here, okay, so this is the contract we've written that's running on ChainLink. We can see the jobs too against this. So that's the one we just ran. So this should be okay now. If we just read against our contract. There, so 13. So now, so the contract has gone out to plasmaLink, and then that's hit Loom, and then it's returned the value back to ChainLink. ChainLink stored it here in that contract. So when their DApp goes and asks for it, it gets that value. Okay, so something else we can do is we can actually do this invocation. So because what we did before was we had invoked the contract on Loom, and that had increased the value by adding another item into this. So then when it should refresh by itself, but didn't have enough time. So 14. So that Loom contract, it has 14 values. And now we know this is going to have 13 because we haven't invoked it to catch up. So one thing we actually can do is we can make this 15 by having this contract do the invocation as well. So we were reading before, and now we can also drive a transaction through there, which is pretty powerful. So we'll confirm this transaction. So it'll take a second. So you see Loom network also, we can see these transactions running through the network. So on this contract, there's a bunch of calls. That's the calls we just did. Here's some testing to get this thing to work. So I have confirmation now. So we should probably give it a few seconds. The other thing is, so this should increase. Refresh. Yeah, so that worked. So we actually had then, so our contract on the ChainLink on the Ethereum network, but our ChainLink contract then invoked that plasmaLink adapter, and then that went against our Loom network contract, and that increased this amount. So when we read, it should actually read 13 because it hasn't been updated, right? So we'd have to then now invoke this read so that it can get the correct value again. We'll give that a second. Okay, so now we have confirmation of that. Don't show me transactions yet, but I should be able to see it here. Or at least here. Yeah. Okay. So let's give it a second. If we read, we should read this value here as well. There. Okay, so that worked. So everything worked. So that's our demo. So it's just showing essentially the basics that it is possible to create this plasmaLink concept that would allow you on the MainNet chain through ChainLink oracles and those smart contracts and to interact with your smart contracts on a plasma chain. So the power actually is that you'd be able to make this be unified so that the user, contract consumer, this application on MainNet wouldn't necessarily need to know all the complexities and challenges that they're dealing with while having something on the sidechain or the plasma chain. So a couple things, like one use case I think is very interesting is, for example, token transfers. So right now, when you're doing token transfers to Loom or plasma chain, you are transferring from your wallet a token. So say link to a transfer gateway here. That is then minting you an NFT token here. And then that allows you to have that balance over here and then be able to withdraw it back into the main chain. But I mean, it's pretty complicated. So you're sending a token into a gateway that's getting minted. You're mapping addresses across these chains. That's a little bit complicated. It's amazing that that's possible and that it works, but it's still a little bit challenging for anyone. And that's complexity that can be hidden. So something like this could actually hide that complexity. So you could have, say, a plasmaLink JS library here. You call a method to, put a token in, transfer a token. And that would do all that. That would map the addresses. That would do the transfer. That would capture the minting transaction hash that you could then use later on. You'd be able to see those balances seamlessly. So you could actually create a seamless experience for the app. And actually, that's better for everyone, even for the sidechain piece of the application. You want to have a consistent experience. You want to have consistent information across both. And you want to remove as much complexity for the users and developers and everyone in the ecosystem. So that's a demo. I think that's everything. So we can, have a look here if you want. You can try everything I showed you. It all should work. Obviously, it's not industrial strength right now. It's just a hackathon piece of code. So there's a lot of things that I haven't tested or worked through. So things may break unless you you do kind of how I did it. There has to be balances on all the addresses, Ethereum, Link, and such. And you have to follow that flow, essentially, that you'd fund the contract because there's no balance right now. And then you have to invoke before you can read, or invoke before you'd be able to see the value on either side here. But it does work. And also there's code. So there's code here. You can take a look. It's not my best work. I was just trying to get to work. But there's some interesting stuff. There's some stuff you probably haven't seen elsewhere. So there's some hooks that I'm using. So I'm using React hooks, modern React style, Redux style stuff with blockchain applications. So that's pretty powerful too, in the sense that you can wait for state changes within your application. So I mean, this is kind of outside the context of what we're talking about. But anyways, the code's all here. You can have a look. Everything's there. It's kind of basic, just to get it working and prove the concept. But there's a lot of potential here. So thanks for reviewing the submission.